Oh, I think I got it this time, y'all. Oh, we're live. Okay, so back to what we were saying. So last week we talked about how parallelograms have two sets of parallel sides, and that makes this side congruent to this side, and this side, my marker quit writing, congruent to that side, right? So last week we set up a little equation where 2a equals 3a minus 5. And then we solved for a, right? So in this case, everybody wanted to move that 2a because nobody wants to have to deal with that negative. But y'all, it ain't that hard. It's actually harder if we move the 2a and then have to move the 5. So if we subtract that 3a, we get negative 1a, and that equals negative 5. And then what happens when I divide both sides by negative 1? I get a is 5, right? And then we turn around and do the exact same thing for this side and this side. So we have 2b minus 1 equals, what does that say? B plus 3? Is that right? I can't see it. Okay. So then to solve it, we're going to subtract b from both sides. And we're going to go ahead and add 1 to both sides. So that gets rid of my b on this side and gets rid of my 1 on that side. And I'm doing 2 steps at the same time, right? I'm moving the numbers and the, Saley, can you see over this? Brandon, can you see? Okay. So, I'm moving numbers and variables at the same time. That gives me b on this side and gives me 4 on that side. So I know that b equals 4. Now, for the directions for this, it said find the value of each variable. So we're done. If the directions had said find the length of the side, we'd have to go plug it in. But because it said find the value of each variable, we're done with that problem, right? So if you look at number 4, you're doing the exact same thing. So I want you guys to try number 4 and let's see if you can get the right answers, okay? I'm going to grab my glasses real quick. Try number 4. Try number 4 on your own and see if you can do it. Try number 4 on your own. You might want to write a utensil. You might want a calculator. Don't sit there like a knot on a log. Do the work. And while y'all are trying number 4, I'm going to get set up for the next part of our lesson. You done? What'd you get? So A was what? 2, and what was B? Did everybody get the same answer? Anybody get something different? If you got something different, we need to go over it and figure out what we did wrong. 25, huh? I feel like perhaps he just didn't do it. Am I good? Am I right? You did it and you got 25?
No, I got 8 plus 2.
Okay. Okay. Now, let's go ahead and look at the next part of our lesson that we're going to do today. So, here I drew, this is the parallelogram from number 2, roughly. Y'all know it's not perfect, but it's a good basic what it looks like, right? Now, if you were a betting man, what relationship do you think would be happening between the angles in a parallelogram? Like, what's your best guess? Y'all don't know this, so this is just a guess on your part. What do you think it is? What do you think about J and K? What do you think's going on with them? You think J and L would be the same, and M and K would be the same? Does anybody agree with Zaylee? I don't know why I started calling you Kaylee. How weird was that? You don't agree with her? What about J to K? Do you think they have a relationship to each other? Any guess what that might be? Best guess, because we don't know. I'm going to teach it, but right now we don't know. You don't know? Okay, so Zaylee's right, but there's more to it than just that. So I want to talk about how we know Zaylee's right. Okay? Let's cover this side for just a minute. Tell me what you see there. Okay, what is there? What do we have? What kind of lines? Parallel lines. And what's that line crossing them called? Transversal. And we know that we're talking about this angle right here and this angle right here. We know they have a relationship. There's something we call that angle pair. Does anybody remember what it is? Same side interior, also known as consecutive interior. So same side or consecutive. I prefer same side. It makes more sense to me. So same side interior, and we know that same side interior angles are supplementary. That means that angle K and angle L add up to 180 degrees. So angle K plus angle L equal 180 degrees. Right? We know that. Okay? What if I take this and I turn my paper and we are looking at these two angles now? What do we know about these two? We know we got two parallel lines there. We know that they're crossed by a transversal. So what do we know about angle L and angle M? They're interior. Are they same side or are they alternate? They're same side. So we know that same side interior angles are supplementary. So angle L and angle M equal 180. Right? So we turn it again. And we look at these two. And we're looking at these angles that are inside the parallelogram, right? J and M. What do we know about J and M? Same side interior. Again, right? Which means angle J, I don't know why I drew that. That wasn't right. J plus M equals 180 again, right? And then if we turn it one more time and we're looking at these two guys right here. I'm struggling. Y'all, these sleeves on my sweater hang up on everything. They knock things off. This is why I don't wear the sweater very often. I think I wore it one time this year, and I think that's when y'all was taking a test. But this morning I didn't think about it. Okay, so if we're looking at K and J, what do we know about K and J? Same side interior again, which means J plus K equals 180 again, right? So if we look at this as a shape once more, we'll notice that, and I'm going to put like a mark here. I'm going to do this just for just a second. So we know that this angle plus this angle is 180. We know that this angle plus this angle is 180. This angle plus this angle is 180. This angle plus this angle is 180. So if we pick any two angles that are side by side, that's called consecutive, right? Any two angles that are side by side, consecutive angles, they add up to 180. So we can pick any two of them that are consecutive, they add up to 180, right? Well, here's the relationship between K and L. Here is the relationship between M and L. What conclusion can you draw about K and M based on that? They have to be the same thing. If you add K to L and you add M to L and you get the same thing both times, L doesn't change. That means that K and M must be the same. K has to equal M. This angle has to equal that angle. Right? And then if we look at J and M, and we... Yes, ma'am. Okay.
Thank you.
Cameron, we're going to finish this lesson today, and then tomorrow this will be our assignment. Okay? The practice side, not this side. Okay, and it's already online, so if you want to work on it or whatever. Okay, so if we look at this, what conclusion can we draw? Based on what I wrote down right here, y'all. J what? J plus M is 180, right? L plus M is 180. So what conclusion? That's true, but what? J equals L. These two have to equal each other. This angle has to equal that angle. Does that match up to exactly what Zaylee said? That was a good guess, Zaylee. Good job. So if we go back to our worksheet, we can apply this. Right? You've got another pair of cute shoes. Those are adorable. What size do you wear? Oh, too big for me. Okay. That's the size my daughter and my sister both wear 10, 10 and a half according to... But girls and boy sizes are different. Yeah. So, like, a 10 in women is like an 8 in men.
I want to sound like 11 in men's.
What?
Yeah, my boots I have are size 11 in men's. And I have a pair of hay boots that are size 11 in men's.
That's some weird sizing, I think. Because normally it's down 2 sizes. Okay. Let's look at this. Tell me what you know. This one's pretty simple. We shouldn't be on this one very long. What do we know? K equals M. So, what's the value for Y? 44. So, Y equals 44. Now, how are we going to find X? Because we don't know L. They didn't give us L. So, how can we find X? Huh?
M and L would equal up to be 180, so 44. 180 minus 44 L, and then L would be X.
Yes. So these two add up to 180. M plus L add up to 180. And we can totally do that. And it will be the right answer. But it's a little bit like going the long way around.
Yeah, you just do M and J.
Yeah, because these two add up to 180. Or these two add up to 180 also. So we can just do 180 minus 44 to get this guy right here. Right? Which is what? 136? Is that accurate? Okay. Now, look at number 5. Number 5, once again, we've got a parallelogram that gave us some information about the angles. This time they didn't give us any angles. So we're going to have to find everything on our own, right? What angles do we know are congruent? We know A and C are congruent. Here's a problem, though. Can we write an equation? Okay, let me rephrase that. Can we solve an equation where we put y plus 9 equals 3x? Why not? Two different variables. You can't solve an equation that's two different variables. You can't do it. So we need to use the two that have both x's, right? But they don't equal each other. They add up to 180. So we write that equation. You don't have to set it up where they equal. You write the relationship that they are. So what is their relationship? Their relationship is x plus 8 plus 3x equals 180. And then we just solve that equation. So what do we do to solve it? What do we do?
Combine the
So,
like terms.
so that's going to be 4x plus 8 equals 180. Then what? Subtract the 8. Good. So we've got 4x equals 172, right? If we divide by 4, 4 goes into 17 4 times. All right, so 43 is our answer. So x is 43. Now, how do we find y? What are we going to do to find y?
We would solve C and then we would set it up equal to A.
Exactly. So we're going to do 3 times 43 to get C. What is 3 times 43?
129.
129. And then that's going to equal y plus 9. So what does y wind up being? 120. So 120 and 43 are our answers. And that should not have a degree symbol. That's not a degree. That's just a number. Okay? Well, I mean, I guess technically it is a degree. But it's not really an angle measurement. It's just a value for a variable. So it's not really a degree symbol. Okay, we got one more piece of information that you got to get today to be prepared for tomorrow. So do y'all remember whenever we were dividing our shapes into triangles the other day? Do y'all remember that? Doing that? Do you remember what I called? Do y'all remember what I called the lines that went across the shapes?
Yeah.
Do you remember what it was? I was afraid you wouldn't. So when you go across the shape from one point across the shape to another point, like this right here. So if I draw this line right here, that line has a name. It starts with a D. Y'all want to take a wild guess?
Yeah.
What did you think? What did you say?
Yeah.
Now, does that even make logical sense?
8.
Huh?
8.
No. Okay, first of all, I already told you it starts with a D, and it's a word.
Distance.
Really, though? I mean, really? I mean, is that even a logical guess?
No. Triangle.
I'm not talking to y'all anymore.
Domestic.
It starts with a D, and it ends with agonal.
Huh? What?
Diagonal.
Oh, triangle.
Okay, so this is called a diagonal. So anytime you go across your shape from one point to another, you have a diagonal. That's what that is. The diagonals are there whether we draw them or not. Okay? So the other day when we were splitting into triangles, I told you couldn't cross your diagonals. Well, that was just for that specific thing. Your diagonals can cross each other. Like, that's an okay thing to happen. You just can't use that when splitting into triangles, right? And in a parallelogram, diagonals have a very special relationship. They cut each other in half. What is the geometry word we use for cutting things in half? Dude, that doesn't even make sense. It is bisect. Thank you, Layla. Bisect is what we use to cut things in half. That's what we say. It cuts it in half. It bisects it, right? So this diagonal bisects that diagonal. Now, what that means is this and this is congruent to each other. And this is congruent to each other. Now, I gotta show y'all something. Because all the time somebody's like, oh, well, they're congruent to each other. No, they're not. And it really is kind of logical that they're not congruent to each other. So let's say, I gotta get over here in front of the camera so anybody who's at home can see it too. Are you making fun of me?
No.
Am I gonna have to hurt you?
No.
Tomorrow you're gonna hurt me?
No. Those, what are they called? The ones yeah. Can I borrow some?
No. Okay, so here's your shape, right? You can see it? Parallelogram. And we know it's a parallelogram because these two sides are congruent and these two sides are congruent, right?
Yeah.
Now, if I have it like this, right? If it's a rectangle. Yeah, it's not a square because not all four sides are the same. So it's a rectangle. My diagonals would be congruent on a rectangle. But if I do this, y'all, it's clearly much longer from this finger to this finger than it is across here. Do y'all see what I'm saying?
Yeah.
Look at that distance compared to this distance. Let me make it more dramatic.
Oh, yeah.
Do y'all see it now? Still a parallelogram?
Nah.
Yes.
Yes, still a parallelogram. But this distance here is clearly much shorter than this distance here. Your diagonals on a parallelogram probably are not going to be congruent unless it's a rectangle. If it's a rectangle, they will be. But if it's anything other than a rectangle, not congruent. But they do bisect each other. So since they bisect each other, they create these little congruent pieces, right? Okay, back to our worksheet. I feel like I'm doing like back to the bus. Did y'all ever watch Magic School Bus when you were little?
Mm-hmm. Yes.
It was my little brother's favorite show, the Magic School Bus, with Mrs. Frizzle. Okay, so here's what we know. We know that these two diagonals bisect each other. That means they cut each other into these congruent segments where y plus 1 has to equal 26. And then over here, x minus 2 has to equal 19. Right? So then we can just solve those. So subtract 1 from both sides, y equals 25. Over here, add 2 to both sides, so y equals 21. Thank you. Those are our answers, and that's not a y, that's an x. I'm a crazy self. That's it. That's all you do. See how simple that was? All right, you guys try number 6. Let's see if you can get number 6. Okay? I'm going to give you about a minute.
46. What number is it? 3, 6, 8, yeah. 4. So, so you add 5, subtract 3. What is it? 5. I'm not. 15 minus 2. Okay. You said 12. You told 12.
Anybody want to share their answers?
12.
What's 12?
Y. X equals 12.
X equals 12?
No, X equals 4.
X equals 4.
Yeah, I got 4. I got 5.
I feel like y'all did it wrong.
I just added the 5, the 10.
Those of you who are getting these weird numbers.
I subtracted the 2 and the 1.
You subtracted the 2 and the 1?
Yeah.
Let's go ahead and set it up and show what it looks like, okay? So we're looking at number 6. We know that 4x minus 2 has to equal x plus 10, right? 4x minus 2 has to equal x plus 10. Right? So then we're going to subtract x from both sides. And let's go ahead and do the constant too. Let's go ahead and add that too. Do it one step. So the x's are gone, the 2's are gone. So we have 3x equals 12. Is that where you got the 12 from? I don't even know what to do with you. Divide by 3. I'll see you later. X equals 4. And then we would turn on to the same thing to find our y, right? So y plus 5, 3y minus 1 have to equal each other. So we would have, you have 3. Y plus 5 equals 3x minus 1, right? So we're going to, wait a minute, 3y. Why am I doing that? Well, because I'm not putting my glasses on, so I can't really see it. Okay, so if I subtract y from both sides, I'm going to add 1 to both sides. See how I can do that in one step, just like that? Save yourself a little bit of paper. Divide by 2. What is y? 3. That's it. Boom! Huh? Huh? I still have no idea what you're saying.
Something like easy one.
I don't know. I'm just going to roll on and pretend like, okay. Okay. Now, look at this next part. It says, find the coordinates of the intersection of the diagonals of, and they give you this list right here. This is important, and we're going to come back to that in just a minute, okay? So, I graphed it. You don't need to graph this. It's not necessary to graph this. I graphed it just so you can see what it looks like. If we're finding where they intersect, what are we finding? Let's back that up. What do we know about them? What do they do to each other? They are diagonals, yes. They bisect each other. Oh my gosh, excuse me. Bisect means cut in half, right? If they're cutting each other in half, that place where they cross is their midpoint, right? It's both of their midpoint. It's a midpoint for JL. It's a midpoint for HK, right? We don't need to graph this, though, because here's the deal, pickles. When they give you the name of any kind of shape, it doesn't have to be a parallelogram. It could be anything. It could be hexagon, octagon, quadrilateral, whatever. They give it to you in consecutive order of the points. Go in either clockwise or counterclockwise. It doesn't make any difference. They give it to you in order of the points. So here's what we know. Since they named this HJKL, we can do a rough sketch. HJKL, right? And that tells us what points make the diagonals. So what points make the diagonals? Well, JL are diagonals. So J and L are diagonals. We could find the midpoint of JL. Let's do that, okay? So we're going to, how do you find midpoint? Y'all remember?
Middle.
Yes, but how do you do it? Like, what do you do?
Find the center of it.
X plus X over 2.
That's the middle.
And then, like, you're going to set it up like it's a point.
Yes.
And then the Y plus Y over 2.
Yes, so you add your X's together,
Yeah.
divide by 2. Add your Y's together, divide by 2. And it's a point. So it has parentheses, it has a comma, right? So X plus X in this case would be 2 plus 5 divided by 2. And then Y's would be 3 plus 1 divided by 2, right? What's 2 plus 5 divided by 2?
3.5.
What is 3 plus 1?
4.
I hate when I do that. Divided by 2. 2.
Pardon the interruption. Please dismiss these basketball players from class at 11:20.
Y'all aren't basketball players and it's not 11:20.
Will Dye, Jesse Parker, Samonche Grant, Liz Reed,
Okay,
Nathan Hudson,
now,
Seth Long. Thank you.
those are not the only, that's not the only way we could do it. We could do it the other way too, right? Because the other diagonal is HK. So we could do H and K. So that would be 6 plus 1 divided by 2 and 1 plus 3 divided by 2. And what are we still going to get? We're still going to get the exact same thing because it is the midpoint of both of them, right? So it doesn't matter which one you find the midpoint of, you're going to find the same point. Well, good. Okay. Tomorrow, you are going to do the practice in class. It's already on Google Classroom for you because I thought we would get more into this today. Y'all probably could have if I pushed a little bit, but first hour we had all kinds of issues. So, but tomorrow we're going to do the practice, all right?